In the last section, we finally tried to test out our k-nearest neighbor algorithm. However, we saw that the results were not that great. So our analysis predicted that we would see a ball dropped at point 300, like right around right there, to fall into bucket number 5. But when we use this little tool right here to drop 100 different balls at exactly position 300, we very clearly saw that bucket number 5 wasn't really the winner whatsoever. So in this section, we're going to discuss a couple of different strategies to kind of vet these results and then try to improve our algorithm to some degree. Now, the first thing I want you to understand is that whenever you implement these algorithms the first time around, very, very commonly, you're not going to see the results that you expect. And so almost always, you'll do some initial implementation and then have to go back to the drawing board and figure out exactly why things did not quite work out the way you expected. So first thing that we're going to do is think about adjusting the parameters of our analysis. You might recall that back inside of our score.js file, we had set k equal to 3 right there. So that meant that we only wanted to consider the closest 3 points when attempting to guess which bucket a ball was going to fall into at point 300. Now, as I said earlier, the use of 3 right here was kind of a little bit arbitrary. So we could very easily start to massage this number and see if we could come out with some greater accuracy than what we got already. The next thing that we could possibly do is add in more features to explain our analysis. Remember, at this point in time, we have only implemented k-nearest neighbor in order to explain one independent variable. So in other words, only the point or the distance away from the left-hand side of the board, like over here, is attempting to be used to explain which bucket a ball will fall into. It might be the case that the actual bounciness of a ball, which remember is a random number right now between 0.5 and 0.55, or the size of the ball has some effect on where the bucket falls. So we could also attempt to expand our algorithm to account for multiple different features inside of our simulation. The other thing that we might try doing is to change our prediction point from 300 pixels. Maybe there's something just a little bit off about that 300 pixel point, and maybe if we tried a different point, like let's say 450, like over here, or if we tried 600 over here, maybe we would have a result that has a little bit more accuracy to it, and that would give us at least a little bit of confidence in our algorithm. The last thing that we might do is at some point in time, kind of accept that maybe there's just not a good correlation between the drop position of our ball and which bucket it falls into. Now, in this case, I'd say that chances are that the drop position does have an effect on where a ball is going to land. Clearly, if I drop a ball over here, it's probably going to land in one of these buckets, and if I drop it over here, it's going to land somewhere over here. So I think that without a doubt, the drop position does have an effect on our output. But for other analyses that we might do, maybe that's not always the case. Maybe we need to go back to the drawing board and really investigate how we are collecting data and try to do a little bit of work to get some better correlation between our recorded data and our predictions. All right, so the first thing you and I are going to do in order to analyze this stuff is attempt to adjust the parameters of our analysis. So we're going to do that by changing the value of k right here. Now, as you might guess, manually changing k a whole bunch and saying like, k equals 2 and 3 and 4 and 5, and manually rerunning our application for each of those attempts would get really old very quickly. So instead, we're going to write a lot of additional code into this file that's going to automatically try out different values of k and then print out some accuracy percentage or some analysis to tell us exactly how correct or how not correct any particular value of k might be. And so by doing this additional analysis, maybe we could come to some determination of what the best value of k might be. So let's take a quick pause right now. When we come back to the next section, we'll start working on doing some additional analysis on what the ideal value of k might be.